Okay, do you have power line noise problems? Do you have a neighbor with a plasma TV that just wipes out your reception on the low bands? Perhaps you live next to an installation that has medical equipment running. Power line issues can probably be taken care of with time. It took me several years because of travel. And I wish I still had my actual power line noise because it was far more dramatic than this demonstration. I had 20 over in power line noise that I could drop down to below S2 or S3. With the little device you see sitting here, this is the MFJ 1026 noise canceling signal enhancer, quote unquote. I don't know where they came up with that name. This is not actually a filter. It's not a noise blanker. This is a phaser. The upside to this is if you have 20, 30, 40 dB of noise from something in your neighborhood that you just cannot rectify. Maybe you have a neighbor who won't let you touch anything in his house. Maybe you, like I say, live next to a welding shop. Something that's just wiping out reception and making it impossible for you to work on HF. This could be your salvation. This is one of those products that actually lives up to the hype. It's unusual in this day and age. Usually things are hyped and hyped and hyped, and when you get it home, you're kind of disappointed. This device actually works. The downside to this thing, nothing's perfect in this world. You need a second antenna. You need a sense antenna. And that can be simple as perhaps a 20-foot piece of aluminum tubing standing on an insulator. I used to use one of the multi-band dipoles, and here's a few examples of those. The reason I used the multi-band dipoles is they were already assembled, readily connected to a coax, and they covered several bands. They covered all my bands of operation and worked quite well as a sensing antenna. The second downfall to this is a little bit fidgety, and we're going to show you how this works. I'm going to turn the volume back up, and I am going to throw this thing out of whack. Ooh, and as you can see now, we have 20 over noise. So we start by turning everything down. Now I'm going to turn up the main antenna only. This is my sense antenna. This is my main antenna. And with the main antenna turned all the way up, I'm a little bit over S9. So we know fully clockwise is S9. So I'm going to turn that down. This side is a little more sensitive, and it does have a preamp in it. And you can see it jumped right up. So there's a little bit over S9. Now we know at this setting, that's a little bit over S9. Fully clockwise, this is going to be a little bit over S9. Then we should be able to find a place with the phasing control that produces a bit of a null. And by manipulating the sense antenna, you see the null gets better and better. What we're doing here is balancing the level of the two signals between the main antenna and the sense antenna, and then adjusting the phase. And the idea being, when the two phases are exactly opposite, one's got its sine wave going up, the other one has its sine wave going down, they should cancel one another. And it is a little bit fidgety. But you should be able to get this thing down to the noise floor, or the natural background noise level that you have at the receiver without any interfering signal. And of course, now that I've disturbed everything, I'm going to have trouble getting it back there. And there are several other controls. There's a phasing control, normal and invert. And you have to play with everything until you get the results you want. There's a high and low frequency knob as well. Sometimes the results are better on the high, sometimes they're better on the low. But if you can't operate, if your filters and your radio won't take the noise out, oh, and there, we're almost back down to the noise level, the natural noise level I have here. But I've run out of range in my phasing control, so I'm going to try something else. There we go. Look at that. That dropped this down to almost S4. Now, unfortunately, I am doing this with a homemade noise generator or homemade noise source, and I am only able to simulate having two antennas up. Since I fixed the noise problem here at the house, I took down the Sense antenna. I've loaned that to another ham. In fact, the radio I'm using for this demonstration is my old 751A. It's also on loan to him. I borrowed it back to do this video. The reason I use this, it's a little bit easier to understand what's going on with an analog S meter. The visualization works better than it does with one of the digital bar graph meters, which is what's on my other transceiver. Now, just to show you that I do have a fairly high noise level here, I'm going to go shut the noise source off. Woohoo! There we go. I'm going to go shut the noise source off and show you what it's like. Okay, the noise source is off. This is just off-the-air background noise that I normally have here on 80 meters during the day. And it's running about S2. Now I'm going to go turn the noise source back on. Okay, the noise source is back on, and as you can see, the background noise level, and this is off the air on my actual dipole antenna, the background noise level is still an S2. If I take the filter out of line, we're almost S10. And again, this is my simulated power line noise. My actual noise that I used to have here was 20 over. I had a badly arcing transformer out at the end of the driveway and absolutely couldn't operate during the day. It was impossible until I bought this and was able to knock that down to the natural background noise level. Now, this does not in any way affect the signal you're trying to receive off the air. This only affects the noise. And the reason it only affects the noise is, as you see in this slide that's up on the screen now, I have the Sense antenna near the transformer, near the noisy transformer. My main antenna is set back about half a wavelength away, connected to the house. Then I can adjust the phasing control here, this phasing control, and the auxiliary gain on this auxiliary antenna match the two levels and null the noise, and I was able to operate. Another downfall with this, however, is if you're using a beam antenna, every time you swing the beam antenna, the signal levels between the two will vary. They'll change. If you aim your main antenna at the noise source, of course, that noise floor will go up. You'll have to increase the auxiliary gain. Also, every time you change frequency, if you will, from one part of the band to another, you'll have to slightly adjust the phasing control. And I'm going to turn this down so it's not quite so noisy. The reason you have to do that is as you change the frequency characteristics coming in, the phase characteristics of the noise are going to change. However, I think that's a small price to pay to be able to operate if you have a condition where there's just so much noise in the neighborhood, electrical noise in the neighborhood from a particular source, that you can't operate. This will get you on the air. Bear in mind, this filter is only for terrestrial noise. That is, sources that are man-made, on the ground, and probably somewhere between 1,000 feet or less, or perhaps up to a couple of miles. If it's something that's 100 miles away, like one of those pulsed radar systems, or if there's a large industrial complex several miles away and you're getting a skywave signal, in other words, a signal that's coming down from the sky, this probably won't work very well because it's difficult to get a phase differentiation, easy for me to say, between the two antennas. But when the signal's coming in from the side and hitting, say, the auxiliary antenna first and the main antenna second, there's a time lag between when these two signals get there, and you can operate the phasing controls, or the phasing control here, and the phase reversal and the high and low frequency, and phase the noise out. What if your property is set up like this slide, where you see the sense antenna is farther away from the main antenna than the auxiliary antenna? That's where the preamp comes in handy. You turn that on and you can raise the level of the antenna. Should that not provide enough gain, you can go with this configuration where you put a couple of phased elements on your vertical antenna. Now, this doesn't have to be anything fancy with a ground plane or anything. You're not transmitting on this antenna, see, we're not worried too much about this being a lossy antenna. We just want to provide some gain in the direction of the noise so that we have enough signal on the auxiliary antenna that we have some room to move back and forth and balance the two signals. Worst case, if the main antenna cannot be matched with the signal antenna, say you can get a 20 over here and this will only go to S10. Well, then it's just a matter of reducing your main antenna down to an S9, and then you can put this one to its max, which is an S10, and do your adjustment on this side using the main antenna. You'll lose a couple of S units of receive signal. Again, a small penalty to pay for being able to operate. But hopefully, in most cases, you'll be able to simply turn this down, take a reference, S9, turn this one down, turn this up to the S9 level, then you know fully clockwise is again going to be S9. You see the noise fell right off, and with some fine tuning, that signal goes down again almost to the noise floor, the natural noise floor, and there it is. Whoops, my hand is interacting with it here. And that's because of my configuration here where I'm simulating the second antenna and the noise source. This device works. I used it for several years until I was able to find the time to deal with the public utility company. I'm going to do a second video on how I finally got them to come out and respond and fix the problem. It involved changing a transformer and dropping a new line on the street to eliminate the noise source. It was expensive for them. It was a pain in the neck for me. I'm sure I was a pain in the neck to them as well, but I was able to finally solve the problem. And again, I'll do a second video on that. So I hope you found this somewhat useful. If you're having problems and the normal filters on your whiz-bang kilobuck radio won't do it, you know, you've got a welding shop next door, you've got a medical facility next door, you've got a power substation next door that just is wiping you out, this can fix the problem. It works. I suggest buying the unit with the preamp. This comes in two versions, with and without the preamp. Oh, and I forgot to mention, I'm going to do a video on modifying this. If you're running an amplifier, you cannot use this as it comes from MFJ. I'm going to do a video on the modifications I did to make this survive having an amplifier, because without it, you're going to blow up. What they use a lamp for a fuse to protect the preamp in here, and it'll simply explode with the RF coming back up your sense antenna. I'm going to show you how to modify this, and it'll take care of that problem, and you can operate with impunity. You do have to use the transmit-receive control line on this. Do not try to run it without it. You'll blow up the preamp. And we'll cover that on another video as well. Again, hope you found this useful. And this is the Radio Mechanic. See you later.